Hello?
Hey, Joel.
Hey, how are you?
Good.
That's good.
So, you're going to work on imaginary numbers today?
Yes, we are.
Okay. Got some problems?
Yes, I do. So grab them quick. All right, so the first one is it says write in standard form,
Okay.
and it's 3 plus the square root of -1. I mean, sorry, -81.
All right.
And
Let's
I
work.
guess what's the difference? Because I know there's conjugate. So what's the difference between standard and conjugate form?
Standard form is A plus BI.
Okay.
And you'll see why that applies by the time we're done with this.
Okay.
Okay. First of all, let's talk about what is this equal to. The way I like to do these, in other words, I know it's an imaginary number because you can't take the square root of negative numbers.
Right.
So that's the first thing. And let's separate it into -1 times 81. Well, I know what that is. What's that?
0?
That's
No.
I.
Oh, I. Okay. Oh,
I,
yeah. Okay.
I is equal to the square root of -1.
All
What's
right.
the square root of 81?
9.
So the square root of -81 is equal to 9i.
All right.
So this would be 3 plus 9i. Notice that's in that format.
Oh, okay.
A is 3, B is 9. This is the real part. This is the imaginary part. This is the coefficient of the imaginary part.
Okay, so the answer is 3 plus 9. Okay, yeah, I get it.
Yes.
All right. All right, the next one is 6 plus 4i. And it says write in conjugate. I mean, yeah, write the conjugate of 6 plus 4i.
Okay, the conjugate is always that. In other words, if it's A plus BI, the conjugate is A minus BI.
Okay.
It's as simple as that.
So, okay, so that is literally just 6 minus
That's
4i.
literally just change the sign on the middle term.
Okay, what does that do? What makes that like the conjugate so-called? Like why?
Well, let's say I have a problem. I want to solve that.
Yeah.
This has a similar problem as we have when we have irrational denominators.
Mm-hmm.
In other words, if I had an irrational denominator, that would not be a satisfactory answer to give. You do not want to give answers with irrational denominators. So I would multiply this by square root of 3 over square root of 3, doing what is called rationalizing the denominator.
Right.
So 1 over square root of 3 is the same thing as square root of 3 over 3, but the square root of 3 over 3 is a better answer because it has a rational denominator. Well, we have the same problem with imaginary numbers. We never want to give an answer that has an imaginary number in the denominator.
Okay.
So to get rid of it, you can multiply any fraction by the number 1 without changing it. Well, in this case, my 1 is going to be the conjugate over the conjugate.
All right.
And what that does is it gets the I out of the denominator. If I FOIL that times that, I get 36 minus 16i squared. In the numerator, I get 12 minus 8i. Okay? Well, believe it or not, that got rid of the imaginary number in the denominator because what is I squared equal to? If I equals square root of minus 1, then I squared equals square root of minus 1 times square root of minus 1,
Minus 1.
which is minus 1. So now I can substitute minus 1 for that, and I got 36 minus a minus 16. This becomes 52.
All right.
And I've rid myself of the imaginary number in the denominator. In other words, this is the same thing that I started with, same exact number. The only difference is that I have eliminated the imaginary number from the denominator. And therein lies the usefulness of the conjugate, because the way you always do that is to multiply it by the conjugate.
Okay.
So let me give you a problem. How are you going to solve that? It looks like a division problem, but it really is not. It is not a division problem. It is a problem that has an imaginary number in the denominator, and we merely need to get rid of that.
I think I'm still confused.
Okay. Well, I cannot divide by an imaginary number. That's not a satisfactory answer.
Right. Right.
Okay?
So you would have to change.
So to get rid of it, I got to multiply by the conjugate over the conjugate. Well, the conjugate is 3 plus I. This number here is 1.
Okay.
So all I'm doing is multiplying this fraction by the number 1. I'm not changing it.
Right.
But what happens is when I multiply that by its conjugate, you lose the imaginary part. Notice what I get is 9 minus 3i plus 3i minus I squared. The middle terms always cancel. So you have 9 minus I squared is negative 1, so you have 10.
Oh, okay.
In the numerator, you still have imaginary numbers. You have 6 plus 3i plus 2i, which is 5i, plus I squared. So now you have 6 minus 1, you have 5 plus 5i in the numerator, and you have 10 in the denominator. And I can actually reduce that to 1 plus I over 2. So that would be the answer to this problem. What is 2 plus I over 3 minus I? It's not a division problem. It's a, what I call, realifying the denominator.
Realifying.
In other words, if I gave you this problem, you would say, I would rationalize the denominator. Well, what we're doing is we're taking a complex denominator and turning it into a real number. So that's why I call it realifying the denominator. It just looks like a division problem. It really is not.
Okay.
Any more than if I said 2 over square root of 7, that is not a division problem. It is a problem that requires us to rationalize the denominator, which I'm going to do by multiplying that fraction by that number, 1. And I'm going to get that. So this is the equivalent of this, but this has the advantage of having a rational denominator.
Oh, okay.
Same thing with imaginary numbers. You have to get the imaginary number out of the denominator.
Right.
You do that by using conjugates. Now, if I had something like this, I don't actually have to multiply by minus I over minus I. I really can get by with multiplying it by that, because the bottom turns into I squared, which is a real number, minus 1.
Right.
top turns into minus 3i, so that becomes minus 3i is the answer.
Right, okay.
Whereas you might say, well, weren't we supposed to multiply by the conjugate? Well, yes, we could do that also.
Mm-hmm.
That gives us minus 3i up there, minus I squared down there, minus I squared turns into 1. We still get minus 3i. So the conjugate is only required when you have a real part to that denominator like that. If you have something like 2 minus I in the denominator, then the only way to get rid of the denominator I is to multiply it by the conjugate. And since you can only multiply a fraction by 1, you have to multiply it by the conjugate divided by the conjugate.
Right, okay.
All right.
So that equals 1. All right, I guess that
Well,
makes more sense.
it doesn't equal 1, but it gets rid of the imaginary number in the denominator. Whenever you multiply an imaginary number by its conjugate, you lose the imaginary number. It disappears. The middle terms take it out.
All right, cool.
What else you got?
All right, so the next one says simplify
Okay.
12i to the power 2 minus 4i plus 7. So I almost feel like all this is more like factoring everything. Like, you know, is that what I have to think of it as?
Not really. I can see why you'd say that here. But it really is a simplification.
Okay.
Let's perform this square. What happens? What do I get when I square that? Is the 12 in parentheses also?
Yeah.
Okay. So the 12 has to be squared, so that's 144.
Right.
The I has
doesn't
to be
the I turn to 1?
Well, it turns to I squared, which turns to minus 1.
Negative 1, yeah.
So if this is negative 1, now I have this. Now I can combine that number and that number, and I get minus 137 minus 4i. There's your answer.
Okay.
Notice that it's in A plus BI format. That's the standard format for imaginary numbers. You want the real part on the left, the imaginary part on the right.
Okay. Right. Let's see. So the rest of it says complete the operations indicated. Final answers must be in standard form for complex numbers.
Okay.
So the first one says 3 plus I, or parentheses 3 plus I, and parentheses plus parentheses 6 minus 4I.
Okay, when you're adding and subtracting, piece of cake. Add the reals, add the imaginaries.
All right, so be 9 minus 3I.
That's the answer.
All right. The next one is in parentheses 1 minus 6i and parentheses minus parentheses 5 minus 8i.
Add the reals or operate on the reals. What do you get?
Get minus 4.
Now, operating on the imaginaries is minus 6i, but this minus and this minus makes it a plus 8i.
Right. So it'd be plus 2i.
That's the answer.
All right.
So adding and subtracting is quite easy.
Yeah, it is quite easy. So then in parentheses negative 2 plus 3i and parentheses minus parentheses 16 plus 7i, which would be negative 18.
Oh, this is addition or subtraction?
It's subtraction.
Okay, I thought it was multiplication. Okay, yeah, negative 18.
Minus 4i.
That's it.
Okay.
Must have a multiplication there. Let's do a
multiplication. Yeah, that's this next one. 2 plus 3i times 6 minus 4i.
Use FOIL.
So it'd be, let me see.
FOIL is the same thing as multiply every term by every other term.
Yeah, that's what I'm doing. So right now I did the 2, so it'd be 12 minus 8i plus 9i.
18i.
18i, yeah.
3i times 6.
Yeah, 18i minus 12i squared.
Correct. Okay, now let's simplify.
So it'd be 12 minus, or no, 12 plus 8i
12,
minus 12i
12,
squared.
12 plus 10i
Oh yeah, it is 10. Sorry, my bad.
minus 12 times a negative 1. So we have 12 plus 10i plus 12. So we have 24 plus 10i.
Right.
Okay?
Okay, yeah.
So almost every single one of these problems, you have to convert that I squared to a negative 1.
Negative. Right.
So
then
make
you're
sure
able to,
you remember, if you know nothing else about imaginary numbers, know that I squared is equal to negative 1.
Alright, cool. Alright, so this next one is the division one. It's
Not really,
4 over...
not really a division one. It just looks like a division one.
Right. It's 4 over 2 minus I.
In other words, I'm not going to do this.
Right.
I'm not going to divide it. So all I'm going to do is realify the denominator. What do I have to multiply top and bottom by?
By 2 plus 1.
2 plus I.
2 plus I.
Which is the number 1. Okay, let's handle the bottom first. What's the bottom become? Notice when you multiply 2 minus something times 2 plus something, you lose all your middle terms. The only thing you have is the term on the left, which is 4, and the term on the right, which is I squared. That's what you get whenever you multiply something by its conjugate.
Right.
Because you get 4 plus 2i minus 2i minus I squared. Well, these two always cancel.
Right. So it's just the first and last term.
Yeah.
Right. And the top, it would just be 4 times 2 plus I. So that's 8 plus 4i.
Yep. What's the bottom equal?
The bottom equals 4 minus negative 1, so it is 5.
Now put it in standard format, because that's not in standard format. In other words, 8 plus 4i divided by 5 equals what if I want to put it in a plus bi format?
I don't remember.
Split it into 2 fractions. You got that fraction, and you got that.
8 over 5, and yeah, okay, so...
Yeah, so it's 8 fifths. That's the real part.
Right, plus 4i over 5.
That's the imaginary part. In other words, if they ask you to put it into standard format, you probably would lose a point if you gave that as the answer.
Right.
Because that's not in standard format. It's the right answer. It's the same number. They're perfectly equal to one another. It's just not in the format that they wanted.
Right.
Imaginary numbers are really quite simple. They puzzle a lot of people, but once you get that I equals the square root of negative 1, you're good to go. Let's go over one more thing. We only got a few more minutes here. I want to make sure we cover this because I know you're going to probably be asked about this. I is equal to the square root of negative 1.
Right.
I squared is negative 1. What's I cubed? Negative I.
Negative I.
In other words, it's negative 1 times I.
Oh.
That's how you would get I cubed, is I squared times I, which is negative 1 times I, so you get negative I. I to the fourth is I squared times I squared, that's 1.
Oh, okay.
And
What do I add to the fifth?
it recycles every time. I to the fifth equals I to the sixth equals negative 1, I to the seventh equals minus I to the eighth equals 1.
Oh.
So tell me what I to the 28th power equals.
One.
What is I to the 500th power equal?
Cool.
Is that divisible by 4?
I don't know.
It is.
Yeah,
It is.
125.
Perfectly. Therefore, it's also equal to 1. What is I to the 502nd power equal to?
Would be negative 1? No, negative I.
No, you got it right.
Okay.
In other words, you divide this by 4, and you get an even number plus a remainder of 2. So you go down to find the exponent that's 2. Whatever your remainder is the exponent. In other words, I to the 7th power, I divide that by 4, I get a remainder of 3. That has to be equal to I to the 3rd, which is minus I. So if you know these first 4, you will be able to answer all questions about I to any power.
Right, okay.
And they will frequently throw in something like, what is I to the 501st power? In other words, they know you can't do it. You can't count that up. So you have to know how to do it.
Right, okay. All right.
All right, Joel, listen, I scheduled back to back to back here, so I'm going to run.
That's fine.
And we have another session tomorrow. Let's see, I have one with your sister at 4 and with you at 6.
Yes.
I will talk to you tomorrow.
All right, cool. Would you mind, because I know you record these, would you mind actually sending me this one, so if I need to, I can go back and look over the imaginary stuff?
Definitely will send it to you. I am recording it. The only problem is that on a day where I have multiple ones, let's see. I can
whenever you can. I mean,
it probably won't be till tomorrow morning. But
that's totally
I will
fine.
almost certainly have it up there by tomorrow morning. Do you still have the page where I put these? You know where on my website you need to go to find these recordings?
I can find them. I'll find it.
Okay, because I can resend you the link if you need it. But it's the same page for you and your sister. One just says Joel, the other one says Marina. So,
all right.
All right? All right, Joel.
All right, thank you. Have a good day.
Bye. You too. Bye-bye.
Bye.